Guys everyone, today we're going to discuss about current mirror using NMOS. NMOS is in channel metal oxide semiconductor. So let's move on to the introduction. So what is a current mirror? A current mirror is a circuit designed to copy a current from one branch to another, maintaining the same current. So in order to maintain the same current into two transistors, we are going to use a current mirror. So why do we use a current mirror? It provides stable current sources for biasing in analog circuits. So in case of using analog circuits, we need a stable current. So in order to provide stable current, we'll use current mirror. And next one is ensures precision and consistency in circuits. Next we're going to see the basic concept of current mirror. So definition of current mirror, it is used to generate a replica of a reference current in another branch of the circuit. NMOS transistor current mirror. So as I said earlier, there are two transistors in this NMOS. We're going to mirror the exact same current to the other transistor. So it consists of two or more NMOS transistors where one transistor controls the current and other copies it. Circuit diagram. So this is the circuit, this is a basic circuit diagram of NMOS. So here we have given power supply VDD is equal to 5 volt. The circuit operates with a 5 volt power supply. Resistor R1 is equal to 200 kilo ohm. It helps control the voltage at the gate of one of the NMOS transistors. NMOS transistors M1 and M2, so there are basically two transistors. These are the main components that control the current flow. M2 acts as a current source or biasing transistor. M1 functions as the main switching or amplifying transistor. Operation: the circuit likely works as an inverter or current mirror, meaning it controls the output voltage based on the input. When M2 is conducting, it influences M1, which then determines the output voltage. So VO is the output voltage. The output voltage depends on how M1 is switching. If M1 turns on, V output voltage is low. If M1 turns off, output voltage is high. So this is a circuit diagram, and we're going to see the working principle of it. Operation: the reference current flows through M1. So we are going to give the reference current to M1 and we're going to exactly copy the same current to M2. The gate of M2 is tied to the gate of M1, ensuring both transistors operate in saturation. So we need both of the transistors to work in the saturation region. So we are doing this process. The drain current in M2 mirrors the reference current in M1 ideally. So in M2 we have the drain current, and this drain current is mirrored by M1. So this is a key equation we've given here. Conditions for ideal operation. So what are the conditions is matching transistors. M1 and M2 must be identical or closely matched in terms of size. So the size and everything should be identical in case of both the transistors. Operating region: both transistors, it must be in saturation region, as I said earlier, to ensure proper current mirroring. Negligible channel length modulation. Ideally, the drain current should be independent of the drain to source voltage. So next we're going to see the improvement, cascaded current mirror. So problem with a simple current mirror is that it gives an earlier voltage effect, and this leads to inaccurate current mirroring. So this is a problem with a simple current mirror. So what is the solution for this is we can add a cascade stage in order to improve or increase the output impedance, and we can also increase the accuracy by doing this. Next we're going to see about the applications of current mirrors. Why are current mirrors used and where are current mirrors used? So current mirrors are used in biasing circuits, used in amplifiers, oscillators and differential amplifiers for stable biasing. In order to make a stable biasing, we use these kind of current mirrors. And analog integrated circuits. So for analog ICs also we use these kind of current mirrors. used in CMOS technology, so for current sources and current steering DACs. Current source for LED drivers to ensure constant current for LEDs. So these are the applications of the current mirrors. Next, we're gonna see the advantages and disadvantages of current mirrors. The advantages is that, as we've discussed earlier, it provides precise current control, and it's very simple to design. It's easy to integrate in ICs, so it's very easy to integrate in integrated chips. Disadvantages are it requires matching transistors. As I said earlier, it requires the same configuration as a transistor we use, like first transistor and the second transistors must be having the same configuration. So for optimal performance, susceptible to variations due to temperature and process changes. In order to make it like valuable, we need to make it valuable with the temperature. The temperature should also be not a problem for those two transistors, so it should be susceptible. So the conclusion of this is, we have seen current mirrors are fundamental circuits in an analog design. It's very useful, and NMOS current mirrors provide a reliable way to generate reference current for various applications. The cascaded current mirror improves performance by mitigating errors in current mirroring. So this is it. Thank you.